Hi again. In my last video, I talked about picking the right motor. Today, I'll be talking about motor gearing. What is motor gearing? Well, it's how we increase a motor's torque or speed rating. The numbers on a motor's specification sheet are not static. We can actually improve a motor's torque or speed rating further. We can't really do anything about the power though, that's pretty static. If you gear up a motor, you can increase speed or torque, not both. Why? Well, that would require me to run some higher level math, but in a nutshell, the math works out so that it's a trade-off. You can increase one, but the other will decrease. Okay, so how does this work? Well, first, you need to get familiar with gears. These things. First, you need to know that gears have something called teeth. It's these spiky-like points on the gear. This allows the gear to easily mesh with other gears and improve either speed or torque. It is also a good indication of how big or small a gear is. A single gear by itself won't do anything. You need to have it mesh with one other gear in order to be useful. At minimum, you'll need 2 gears for one motor. By placing one gear onto the output shaft of the motor and having it mesh with the other gear like in this picture, you can change the output motion of the motor. What we have here is usually called a gearbox. Now here's where things start to get interesting. If you take a small gear, or one with little teeth, and have it mesh against the big gear with lots of teeth, you will find that the output motion of the motor is now slower, but it will be able to lift more. Conversely, if I switch the two, then the motor will now run faster, but won't be able to lift more. Why is that? Well, let's think about this logically. Think of gears like wheels. A small wheel will spin a lot more than a big wheel if you apply the same amount of force to both. By having a small wheel run against the big wheel, the small wheel will have to make many more rotations in order for the big wheel to run one. That is how the output motion gets slower. However, energy cannot be created or destroyed, only transformed. In this case, your output motion is now stronger. It has gained some torque. Remember, you can increase torque or speed, not both. If you go from a small gear to a big gear, you increase torque but lose speed. If you go from a big gear to a small gear, you lose torque but gain speed. This 2-gear setup is the simplest way of increasing speed or increasing torque. What about more than 2 gears? If you want more than 2 gears, then you'll have to sit down and do some math. I'll be covering this in a later playlist since this video is only an introduction to the principles. Okay, in addition to being able to increase torque or speed of a motor, gears can also transfer motion into a different direction. Motors spin in a circle when you power them, but you can make them move things in a line with special gear sets, such as the rack and pinion or Scotch yoke. There are also gear sets out there that can massively increase torque, such as a planetary gear set, or move loads over a distance, like a bike. Additionally, there are gearing sets made for transmission drives in vehicle-like robots. The 2 most well-known are the Mecanum drive and the Swerve drive, both made by gearing up the ordinary motor. There are tons more out there, and if you wish to know more about the gear sets that I mentioned, Google is your best friend here. Remember that gearing is what turns the ordinary motor into something extraordinary. In my next video, I will focus on how to pick the correct power source for your motor. Don't forget to like and subscribe. Thanks!